Back working on the Lunar Rover here. I ended up burning out both of our speed controllers. So before we put a couple fresh ones on here, let's open these things up and see what I fried. Well, I know what I did wrong. This is our derailleur or speed control plug. Then these three wires are the speed control plug for our second speed controller. And these three wires will be the three wires to go to the throttle. Red's your power, black's your ground, the third color is your signal. Same here. Red's your power, black's the ground, red's power, black's the ground, third color is the signal. And over here, red's power, black's the ground, third color is the signal wire. So the red should go to the red, should go to the red, so all your powers are common. Your black should go to the black, so all your grounds are common. And then your signal should be the same. The blue, the white, and the blue. Well, on the throttle plug, I inverted the power and the signal. So the throttle power from one speed controller was connected to the signal power of the other speed controller through the throttle plug. So we had our 5 volts going to the signal of one speed controller and the signal of the other speed controller going to the 5 volts of the throttle. So it was all messed up. So when I did my test ride with the 2 throttles, the front controller quit working almost immediately, and the rear controller, when you press the throttle, would make the rear wheels break loose and like it was full throttle right off. Well, I would say that was why, because we had 5 volts from one speed controller going right to the signal of the throttle. Well, a few things I noticed right out the sticker that they have on here is 36F, and it shows the 48 volts 1000 watt. The voltage is 48 volts DC, output 1000 watt. But then that's covering a sticker that says, and it's kind of written on there, but 800 watt 30 amp, still 48 volt DC. So I don't know if that makes a difference, but I noticed that. And then here is the actual wiring definition or directions that they give you with the speed controller. So let me see here. A big black and red wire is our power wire. That's the power in from the battery. And the blue and yellow, big wires and big plug, is for our motor. And the lock, on off, for some reason has 3 wires, but then they're jumped down to just 2. That would be this guy. Let me see here. That would be this here. This is the, well, what's left of it, the power lock switch. But so it's got 3 wires, 2 reds and an orange, but the 2 reds are just looped together. So this red on the right is really not necessary. Also, I noticed in the wiring definitions it shows a red, orange, and an orange. And then a red and orange grouped together. And then one orange is your extra. But that's not the way it is on the thing. On the speed controller, we got 2 reds and 1 orange. And then also, I noticed that all these reds, basically all of the reds, are a common power source. And these three common power source red wires are charge wire, shows on our definitions here, charger, one red wire by itself, and then the two wires going to our lock plug that are looped back. So as I said, I'm thinking one of these red wires are not necessary. So these three red wires are full pack voltage, and they're always on, constantly. That's where you get your charge, and then the power to turn on the whole speed controller. The power goes into your switch plug. Then once your switch closes, it sends the power from the red wire through the orange wire. That's this guy up here. Then now this would be your switched full pack voltage. So that's from the lock button key switch is connected to there, and also the indicator, orange wire, and I don't know why it's labeled but the car, but that is your reverse. So if you notice, all orange wires are switched full pack voltage. All red wires are non-switched full pack voltage, except for the one red throttle power wire. I don't know why they do that. That'd make it confusing. Remember, this is only 5 volts to supply 5 volts of power to your throttle. So all the three red commons, those are all full pack voltage, non-switched. And then you got this other red here. Let's see if I can fish it out. Very unprofessional, but that's this guy. That's your 5 volt power supply for your throttle. Comes in a total different spot here. And I guess now that we're up to that, I think that's where our problem, our malfunction or failure was. Because everything, if you notice on the circuit board here, I don't know how clear it is, but all these lettering is nice and clear, except for right here. Seems to be a little bit of maybe heat damage. And that's your 5 volt power supply. So I've got it disconnected so to show where it's different for the throttle. And then right next to it, this blue wire, is our throttle signal. So just to be clear, our throttle circuit is a common ground from our common ground. All the black grounds are common. This blue signal wire, and then this red 5 volt power supply wire. And as I said, that's where it seems like the only thing I can see wrong is a little bit of heat damage right there between the power supply and the signal, the 5 volt power supply and the signal. Could be other. I'm just not sure. Another thing I noticed is kind of weird is we have 2 brake plugs, both marked the same brake, both have yellow and black wires, and usually one's for a brake switch to go to like your brake lever. That way when it's the switch, or when you activate your brake pedal or brake lever, it activates a switch to turn on your brake light, but also it tells the speed controller to cancel out power going to the motor. So usually there's one plug that's a switch, and then one supplies the power back to your brake lights. But on this, I noticed that both the blacks are common, and also both yellows go to the exact same, are soldered to the same terminal. That seems kind of odd. Okay, but other things I noticed, seems like it's got 3 relays that are listed as songles, 14 volt DC, normally open 40 amp, normally closed 30 amp, and they're 48 volt DC. And all 3 of them appear to be the same. Got these blue capacitors, seem to be labeled as 220 UF and 63 volt. I'm not sure if you can see that, but. And then these fellas up here, I believe are our MOSFETs. Let's see if I can get this a little bit more. And I noticed the first one is, well, the first 2 are labeled FHP 20100, but then they have different, I guess, model numbers. First one's a 6GC7. The second one's a 7GC7. And then the right 3 MOSFETs, I think these are the MOSFETs anyways, all seem to be the same. And they're kind of connected commonly. Let's see on the back side here. Okay, well. Alrighty. When I first, the front speed controller failed first, and then the rear speed controller failed. But before the rear speed controller failed, I took voltage readings. With the front speed controller in the failed mode, while it was off, the power lock showed full pack voltage, and the charge wire showed full pack voltage, which makes sense. They're both connected to the full pack voltage constant. Then when you turned it on, of course, the switch connected, so you had full pack voltage on the power wire going back to the speed controller, and then also that activated our orange wires, which was for the reverse, the indicator, and, well, the charge is still constant. But then the thing I found was kind of odd was the power supply for the throttle was only showing 1.9 volts. Didn't show any off, which is normal, but then it should have been showing 5 volts, 4.6, 5, something like that. Now the speed controller that worked, when it was off, we had the constant same things, full pack voltage at the power wire for the lock, and also at our charge wire. And then when I turned it on, we had full pack voltage at the power wire, and at the power wire going back to the speed controller. Our orange wires were powered up, our charge wire of course, and then like normal, the throttle power was showing 4.6 volts. But then, like I said, the next day when the rear speed controller failed, everything still showed the same except for our throttle power supply was only showing like 0.8 volts, less than even a volt. So that's what we fried out on the second one. I haven't even opened it up, but. And I drew up a wiring diagram for our Rover to help decipher what went wrong and stuff. And another issue I noticed was, originally I only connected a reverse for the front speed controller, figuring why do we need four-wheel drive and reverse. So the rear speed controller had reverse capability, I just didn't hook it up. But then now, in retrospect, if you think about it, everything would work fine as long as I didn't hook the throttle wires crisscrossed, until the reverse switch got engaged. The normal operation, when you hit the throttle, it sends the throttle signal, as long as it's not crisscrossed again. In a normal situation, your throttle would send a signal to both speed controllers of how fast you wanted to go, and then they would send that signal out to the motor. Everything would and should work normal. But in this situation, when you flip your reverse switch and attempt to go backwards, this speed controller tells this motor, the front motor, to operate in reverse. The rear motor, because it's not hooked up, didn't get the memo. So it still wants to go forward. So, yeah. This one wants to go backwards. This one wants to go forwards. Note to self. Don't do that again.